Hi everyone, in this video we'll be exploring an application of the Sine Law known as Lami's theorem. It's very helpful when we study forces on an object. So say we have a body, okay, any object, and it's under the action of three forces, okay, namely F1, F2 and F3. So let me call this F1, something like this, F2, and something like this, F3. Okay, and the condition is that the body is in equilibrium. So what does this mean? This means that the sum of all the forces on the body is 0. Okay, so vectors included. Okay, the sum of the magnitudes is not 0. You have to include them in their vector form. Okay, now what we are also given are the angles that the forces make between them. So this angle, we call this alpha, we call this beta, let me call this one as gamma. Okay, this is what is given to us, and we need to find out a relation between all these three such that this body is in equilibrium. Okay, now first we can write F3 as minus of F1 plus F2. Now this allows us to think this in a slightly different way. There are two forces, F1 and F2, they act on this body, okay, these two, and they have some net force. Okay, so F1 plus F2 give you, let's say, F4, some net force. Okay, so F1 is in this direction, F2 is in this direction, F4 is in, let's say, this direction. Okay, and F3 counteracts the minus sign. F3 counteracts F4. So F1, F2 give F4, and you apply F3 in the opposite direction of F4, and the magnitudes have to be equal. So magnitude of F3 should be equal to the magnitude of F1 plus F2. Okay, and since you have called F4 F1 plus F2, this is equal to magnitude of F4. Okay, so using this we can use the parallelogram law of addition. So I'll just show you how it's done. So let's say this is your F1 vector and you add F2 vector to this thing. So F2, and you need F4, which is F1 plus F2, which has a magnitude of F3. Okay, so this is how your F4 will look like. Okay, so F2 plus F1 will give you F4, and F3 will counteract this force. Now here's the thing, the magnitude of F4 is the same as magnitude of F3, so we can call this length, since the magnitudes of vectors are given by the length, as F3, this length as F2, and this length as F1. Now let me mark the angles. So this angle between F1 and F3, so F1 and F3 is beta. Angle between F2 and F3 is alpha, or the angle opposite to F1 is alpha, the angle opposite to F2 is beta, and the angle opposite to F3 is gamma. Okay, So if this angle is gamma, this angle will also be gamma. We are trying to find a relation between f1, f2 and f3, so we'll find this triangle and we are trying to relate angles in this triangle to alpha, beta and gamma, so that we can use the sine law and then find a relation. So this angle is gamma, okay. This angle is pi minus gamma, okay, they form a linear pair. So if this angle is alpha, okay, this one, then this angle is pi minus alpha, okay, and if this angle is beta, then this angle is pi minus beta, and so will be this angle, because they form alternate interior angles. This is pi minus beta. And now you see we have a triangle, we have the side lengths f1, f2 and f3, we have the angles pi minus alpha, pi minus beta and pi minus gamma, and now we can use the sine law, okay. Sine law basically states that f1, write this down, f1 upon sine pi minus alpha equal to f2 upon angle opposite to it, pi minus beta, sine pi minus beta equal to f3 upon the sine of angle opposite to f3, which is pi minus gamma. Now we know that sine pi minus theta is the same as sine theta, so we can say that f1 upon sine alpha is equal to f2 upon sine beta is equal to f3 upon sine gamma. So f1 divided by sine of angle opposite to f1. So this is f1 upon sine alpha equal to f2 upon sine beta equal to f3 upon sine gamma, and this result is known as Lami's theorem. So it's a very useful theorem when you have an object which is acting under three forces. So normally if you want to use Newton's laws, then what you do is that you make a coordinate axis, resolve the components, get two equations and two variables and then solve it. It works, but sometimes it's messy, and this really allows you to simplify your calculations. Now let me demonstrate to you using an example.